For decades, humans have worked tirelessly to expand our reach into space and detect another planet that might reflect our own, planet Earth. Really, the search goes back beyond mere decades, but rather centuries upon centuries, as humankind has always looked up towards the heavens and wondered if out in the great beyond, a planet like ours exists, with green fields and deep blue oceans and a world built by biology. While we haven't always understood the skies and stars to be roadmaps into the greater universe, it hasn't voided us the opportunities to sit back and wonder. Are we alone in our biological existence? Does life flourish away from Earth? Can the absolutely perfect circumstances to harbor life on a planet occur anywhere else? Or is the thought so astrologically impossible, the odds of life happening else are essentially zero? As technology develops and our abilities to canvass the cosmos accelerates, space agencies have found a collection of exoplanets and other planetary objects that may or may not resemble Earth, whether it's their size, proximity to their host star, or their chemical makeup. Recently, NASA was able to publish findings on the newest of these Earth-like planets, using the extraordinary tools found on the James Webb Space Telescope. To hopefully paint a better picture of the potential these rocky exoplanets provide, here's a deeper analysis that assesses a question becoming all too regular. Did NASA just find another Earth planet? The exoplanet in question, officially named LHS 475b, might be the main subject, but its discovery was only possible due to the real star of the show, its host star, appropriately named LHS 475. LHS 475 is a red dwarf located within the constellation known as Octans here on Earth. The star itself is found about 40.7 light-years away from our own solar system, and was faintly detected in the deep southern sky hemisphere by a French astronomer named Nicolas Louis de Lacaille in 1752. Fast forward about 270 years into the future, and the LHS 475 was back in the sights of astronomers and researchers alike, analyzed by the Transiting Exoplanet Survey Satellite, or TESS, as a part of NASA's Explorer missions. When the transit data was delivered to NASA, they noticed patterns that hinted at a planetary system. And not only was it a planetary system, but a system that included an exoplanet and deserved even further analysis. Thus, NASA turned to its prized new instrument, called the James Webb Space Telescope. As a quick debrief, the James Webb is used in a variety of infrared projects canvassing outer space. It's the largest optical telescope of its kind, and can provide clear images of faraway objects and old, fainting light sources that the Hubble Space Telescope cannot define. One of the many brilliant features of the James Webb is its ability to characterize the atmosphere of smaller exoplanets, or objects that are right around the size of Earth. Currently, the James Webb is the only optical telescope that can do as such at longer distances, making it a vital resource after the discovery of LHS 475's planetary system. After months of diagnostics, research, and peer-reviewed studies, the findings on this newfound exoplanet 41 light-years away, called LHS 475b, were published in January of 2023 and brought forth tremendous excitement to the astronomical community. One of the first notable features to 475b was its size. The exoplanet is just around 99% the size of Earth's diameter, as confirmed by the near-infrared spectrograph aboard the James Webb Telescope. The second notable feature that captivated researchers was its estimated terrain. LHS 475b is observed to be a compact, rocky planet with a terrestrial surface, much like Mercury, Venus, Earth, and Mars here at home. These findings were brought forth through transmission spectrum analysis, which was also utilized in an attempt to decipher the atmosphere of the planet as well. Unfortunately, these results are not concrete. The spectrum was analyzed as featureless, which usually hints at a planet having zero atmosphere. However, that's not a tried and true rule, rather just a suggestion. One atmosphere they can rule out with certainty is a methane-based atmosphere. These types of exoplanets and other satellites usually come with thick clouds of methane, just like the ones found covering Titan, Saturn's largest moon. Coincidentally, Titan is the only moon confirmed to contain an atmosphere of significant density, and gives astronomers hints at what other methane-based space objects might look like. In reality, there are plenty of exoplanets that also appear featureless on the transmission spectrum, but do contain atmospheres. Most commonly, planets with a carbon dioxide-based atmosphere tend to show these readings after their analysis. This is due to the compact nature of 100% carbon dioxide atmospheres. These exoplanets appear so dense, detecting an atmosphere at all is difficult. As is the case for 475b, more testing is necessary to rule in or out an atmosphere, if one does exist. These tests usually run 6 to 12 months, as finding more spectra involves lengthy observation periods. Of course, the number one follow-up question to the lack of an atmosphere is, can life still exist on such a planet? Obviously, if 475b doesn't maintain an atmosphere, the answer is no. And if the atmosphere doesn't include oxygen, humans, animals, and plant life forms as we know them wouldn't exist either. And yet, that doesn't mean there aren't life forms in space that can't live and thrive under other circumstances. Anaerobic microbes, or microbes that only live and flourish without gaseous oxygen, are one example of a life form that might exist, or whose relatives might exist, in a carbon dioxide atmosphere. Another sign researchers will be looking for is the presence of clouds, and more specifically, clouds that we see on Venus. Venus is also a carbon dioxide-based atmosphere, which allows for infinite, never-ending clouds to form around the surface despite the planet's extreme temperatures. Temperature is also what helps make Venus a worthy comparison study to LHS 475b. While the newfound exoplanet is 99% the Earth's size, it is almost 60,000% the Earth's mean temperature. Just a month after the findings of 475b were made public, the National Oceanic and Atmospheric Administration published a report that currently holds the Earth's equilibrium temperature at around -1 degree Fahrenheit. This pales greatly in comparison with 475b, which comes with an equilibrium temperature of 595 degrees Fahrenheit. Even when you account for the greenhouse effects of Earth's lower atmosphere raising the mean temperature to 57 degrees Fahrenheit, it's still a 1,000% difference. The extreme temperatures are magnified even further when you account for dayside temperature, where the surface temps of 475b are estimated to reach 887 degrees Fahrenheit. These readings are similar to the temperature readings on Venus, which boasts a hotter temperature than Mercury despite being farther away from the Sun due to its own greenhouse effect. Depending on if 475b contains an atmosphere, there's a chance these dayside temps could run even warmer, especially if carbon dioxide is in play. There's also a chance a different form of atmosphere coats the exoplanet, which could cool the planet drastically compared to these numbers. The final and fastest clue received by NASA during their initial studies related to LHS 475b's orbit. Researchers discovered the exoplanet revolves around its red dwarf in just 2 days, utilizing the light curve readings by the James Webb Telescope. In the end, there were more differences than similarities between 475b and our own planet, but that doesn't make the planet's discovery all for naught. An atmosphere still has yet to be officially ruled out, and despite the planet's close proximity to its host star, the temperature of 475b also doesn't necessarily mean surprises aren't awaiting us on the planet's surface. Red dwarf stars are notoriously cooler than other stars, such as our own sun, If an atmosphere is keeping the planet cooler than its 600 degrees Fahrenheit equilibrium temperature, there might be so much more that meets the eye. Further research into 475b will also inform the future research into other exoplanets as well. There hasn't really been the technology for space agencies to go out and look for Earth-sized planets orbiting smaller, cooler stars, such as red dwarfs. Now that we know that the James Webb delivers results with the precision needed to hone in on these types of missions, less red dwarf orbiting exoplanets will slip through our fingers, and more information about the universe at large will enter the fray. The question still plaguing everyone's mind is this: if the circumstances play out right, what kind of life could we expect on a planet such as LHS 475b? First things first, there probably wouldn't be human or humanoid life, at least not in the form that we know it. Humans like you or I cannot withstand the extreme temperatures found on this exoplanet. And even if the surface level heat is cooled by an atmosphere, who's to say the atmosphere would sustain us anyway? Humans need oxygen and an assortment of other atmospheric conditions to hit just right in order for us to live. It's more than likely 475b doesn't have either the atmosphere or enough oxygen to support humans, smaller animals, or even plants to survive, even if it can't be ruled out. More than likely, if life forms do exist on the volatile surface of 475b, it comes in the form of the aforementioned microbes that thrive in CO2-rich environments. There's also a chance other microbes or microscopic life forms exist on the planet, life forms that defy the rules of biology here on Earth, but may flourish in other extreme circumstances. If 475b was covered with methane, what if life found a way to thrive in such conditions that we haven't seen either here or on Saturn's moon of Titan? It sounds illogical, but with its size, shape, terrain, and potential for an atmosphere of some mysterious kind, the possibilities are endless, even if it doesn't involve methane. One thing is for certain: if further research finds the planet does contain an atmosphere, or that the conditions are thought to sustain life, it would be beyond this lifetime and the next 700 lifetimes before we could find out what lurks on the exoplanet's surface. With the technology that we have now, to send an object 41 light-years into the cosmos would take over 60,000 years, and that's not accounting for accidents, power sourcing, and the other unknowns in our universe. More than likely, the probe would never see the light of the red dwarf in question, and the mission would be nothing more than an exercise in futility. Nevertheless, we'll look back at the newfound information regarding LHS 475b as a hopeful beacon for the future, guiding us in the direction we're meant to go, so that the next Earth planet can be even more discoverable, and, if luck breaks our way, even more lively.